Thank you for the introduction.
You're welcome.
All right, let me get plugged in. No, not this one. This one. All right. Yeah. So today we're going to talk about an experience that I had in improving a code base. But first of all, I'm actually a wizard. Fun fact. And I even inspired some paintings. So yeah. Anyway, today we're going to talk about a real-world example. So does your build time keep getting longer, right? So then you split it into packages, right? Like maybe you can, if you split code, then there is less thing to build. But then the time to build in the application got even longer. And then it's hard to keep up with the version of modern tooling, right? A new bundler is out in 2 or 3 years now. Well, it was the same at Hasura. The build time was about 15 minutes. The reload time in dev was about 5 minutes. So you made a change. You waited 5 minutes. Long minutes. And then you see your console log that popped up. Well, it's not the right one, so you try again. And we didn't have proper tooling everywhere. I still want to shout out Alexandra that spoke this morning. Thanks to her, we at least got TypeScript, so yay. But it wasn't perfect. So we had to make a change, right? And this is the story of this change. So first, who am I? So I'm Nicolas. I work at Payfit as a staff front engineer. And yeah, I still do front end, even though I do a lot of back end stuff. I'm also an NX champion, and recently, but this is not because I'm an NX champion. I will say use NX every time. Use the right job use the right tool for the right job, right? Side note: we are hiring. We are looking for a senior front-end and designer system engineer. So come join us. Most of the teams is actually at the conference, so you can do the interview live if you want. Anyway, so what was the setup, right? So we had our open source code base that then we bundle through an exterior of Webpack into a library that we then imported into the enterprise code base, which was closed source and private and such. But then the tooling was not the same everywhere, right? I mentioned TypeScript, and yes, we have it in the open source code base. We also had ESLint, Jest, even had Storybook, right? Woo, for a legacy project, that was very nice. And snapshot testing, so we know when the story didn't look good, and some end-to-end tests, right? What about the pro code base, right? Remember, this is what we are selling to customers, right? We had JavaScript, we had ESLint, and we had some Jest, which was recently added. And that's it. No storybook, nothing, no types, nothing at all, right? So that's not it. That's not just the big part. To do this, we had 1,000 lines of custom Webpack to be able to wrangle everything. The log file management issue was a mess, because if you had one different version, if you're in your log file in one of the two packages, the application broke in production. Remember, we didn't have end-to-end tests in the other code base, so a lot of manual QA, every single PR we made. Yay, always fun. And the CI was extremely slow, 15 minutes just to build the app. I'm not mentioning lint, test, and whatever. So we wanted to have a proper monorepo, right? We wanted to have a proper system that is unified, a single system that was cohesive. And so we made a shopping list, right? What do we actually wanted? So first of all, we wanted task orchestration. We can say, to build this, you need to build this one before, for example. We wanted to be able to see the graph, right? We wanted to be able to visualize easily what's going on inside of the workspace. We wanted to have consistent tooling, so no 5 version of Jest, no X number of config for Vite. We wanted to have project constraints to be able to say you cannot import the pro console from the open source one, right? Because then it's not open source anymore, or pro anymore. We wanted to be able to have that distributed task execution, to be able to say we want to be able to scale the CI by splitting tasks between runners and to be able to have things faster in terms of distribution. We wanted to have code generation. We wanted to be able to say just create me a new library and I don't care how it's done, just want a new library. And the nice bonus that we want, and that's it. That's afterwards. So then we looked at the tool, right? What existed? So we looked at the ecosystem. First of all, a small disclaimer. This was done a bit in the past, like 2 years ago. So the landscape changed, right? There is new players in town that are not mentioned here. MoonRepo, for example, is quite new. And if you're looking into MoonRepo, you could also look into Moon. It's quite nice. I also wanted to shout out every single engineer that works on those MoonRepo tools. They are amazing, every single one of them. They are always ready to be supportive and to help. So shout out to them. All right, so what did we look into? First of all, Bazel, right, by Google. If you've done Bazel in the past, congrats. It can be quite complex to set up properly. It's made by Google, it's used by Google, mainly by Google, or like very large enterprise customers. We looked at Gradle, because yes, you can do other things than Java with Gradle. In one MoonRepo that I worked at, it was Go and Java and JavaScript, and was all managed by Gradle. Right? It's not just Java. We looked at Lerna, the historical JavaScript MoonRepo kind of like tooling. We looked at NX, because I've used this in the past in the Angular world. This project was in React, obviously a React conference. Then we looked at Pens, and yes, this is a real MoonRepo tool. And this is the real logo, and I love it's so funny, I love them. And they're quite used, but like by big enterprise, and they don't make a lot of fuss on social media and such, but quite good. And then we had to look into Turbo, right? Like all the hype, Versal, Triangle Company, everything, right? So Turbo is in there. So, all right, let's see. Let's get one item by one item, right? So we wanted task orchestration, and they all could do it, right? Like task orchestration is the base of a MoonRepo. Just build the library before building the app, right? So everything was good there. Then we looked at dependency graph visualization. We wanted to see like what's happening in our graph. Well, Pens doesn't support it. It's in progress, but it doesn't, right? Gradle doesn't support it either. You can build your own stuff, etc., but we don't have time to build a MoonRepo tool to build a MoonRepo. We just want to build the app, right? So this was out of the question. Then we look at consistent tooling. So Turbo, don't have it. Lerna doesn't either. So those are out, which means Gradle, Bazel, and NX. We then look at project constraints. They both support it. Good. We looked at distributed task execution. They both support it. Good. We looked at code generation. Bazel doesn't support it. Right. So in the end, we picked NX, because that's the one that matches all of our needs. I just want to say, it's not because a MoonRepo tool is crossed here that is not useful for you. Right? Some MoonRepo are very beneficial, for example, for Bazel. You can have tasks that runs on the CI for you, even if you don't have the resource locally. Or TurboRepo may be enough for you, right? It's not because in this case we chose NX that you should choose NX. It's just that that's what worked for us. All right, so if you want to learn more about those, there is a great site called MoonRepo.tools, and I got all the links in the end if you want to, don't worry. They have a great comparison between all of the MoonRepo tools that exist, between like Bazel, Lerna, and even more. Like Moon is there, Rush is there, also by Microsoft. So if you want to dig more into, if you want to learn more about MoonRepo, MoonRepo.tools is really great for that. So all right, so now that we know we wanted NX, but there is actually two flavors of NX. One is package-based and one is integrated, right? What the hell do they mean? Package-based behave like PNPM /LAN /NPM workspace, right? You just have packages, and then they are isolated, and they have build scripts and such, and everything is standard. You do not have consistent tooling. You just have scripts, like you do in a classical YARN workspace. And the migration is way easier. You slap an nx.json at the root, and then you're in NX, basically. But there is still build step between all the libraries, which is what we wanted to avoid, because we wanted to like have a fast dev server, right? So then we look into integrated. Integrated means that every tool is integrated into the workspace. So it means that, for example, TypeScript knows the whole workspace when you build something, or like Vite also knows the whole workspace when you build something. Every tool is consistent. Because you have one version of everything, of like Vite, for example, in the whole workspace, you only have one version of Vite, one version of Jest, one configuration source of Jest and Vite and such. However, the migration is a bit more thoughtful. Right? You need to make sure you do things properly, unless you can break stuff. But do you have optional build steps between libraries? meaning that you could have something that is way faster and have build steps in some specific cases that you may need it. But if, for example, your small utility library, you're not obliged to build it, which is quite nice for that. And you have plugins. So what is a plugin, right? Because a plugin can do three things. It can generate code. So NX generates React library. Everything will be baked in, set up properly, testing, build, everything is done for us. Executor, which wraps like Vite, for example, to be able to configure it automatically for you. And most of all, automatic migrations. An example was just released a version when I was still there, and we had to update it. Well, when we update NX, it also updated our Jest to use the new syntax from Jest, so we didn't have to migrate our code to the newer Jest version. NX did it for us. And it works quite well, 95% of the time. Like always in IT, nothing is perfect. And there is a new thing in town called NX Crystal. I don't go too much into detail into this presentation because this was not out when we did the migration. But if you have to do the migration now, use NX Crystal. Way faster, way easier. All right, so everything is good, right? Like everything is fancy, everything is good. Like there is always trade-off, right? Like it depends, right? And yeah, there is two big ones. First one is single version policy, right? In an integrated NX workspace, you can only have one version of a dependency in the package, meaning that you cannot have two versions of React in the same workspace, meaning that you cannot have two versions of Vite in the same workspace. It's recommended in a monorepo anyway, even not using NX, right? It's easier to manage, it's easier to evolve things. And it's kind of like the buy versus loan with interest kind of like philosophy. When you want to migrate like React, for example, then you do it like one huge work. But then if you have multiple versions, then you spend one week there, and then you move to another topic, and then you have to regain the context again. It's like, how do I migrate again? Then do another one, etc., etc. And so it keeps getting longer, right? Like anyone tried in a large enterprise context to update a version of any tool knows the pain, basically, right? The second thing is buying of tools. So we have to wait for NX to update the tools and the way they wrap it. However, now that they work hand in hand with engineers, like we saw NX in Anthony's slides, because NX works with the V team now to be able to be up to date and work good for it. And there is plenty of escape hatches, right? Like if you actually need the latest version because you are on the cutting edge in enterprise, I don't know. But if you really want it, you could, right? Doesn't mean you should. And with NX Crystal, it's way easier because it's all magic now. Oh, great. Cool. So how do we proceed, right? Like we know what we wanted to do. We want NX. We want in integrated. We know the limits of it. So how do we migrate stuff? We have some big requirements for this change. We wanted no code freeze, right? Like we couldn't say like for 6 months halt everything. That's just not possible. We wanted as little regression as possible, right? Like no bugs. Hopefully, we'll see. We wanted to adhere to the NX standard as much as possible to assure less maintenance over time, right? Like use the standard, then you should be good. Furthermore, we wanted to, like, if we have standard tools like Vite, like Jest, like Storybook and such, you can reuse the skill from outside back into the work. And same when you hire engineers, it's easier to have them step up to the context. And nice to have, keeping the 7 years of Git history. Because at this point, you know that the Git history is your only savior in case of a bug, and you find a weird thing. It's like, oh, when did this change? Oh, 5.5 years ago. Maybe that's why. All right, so here's how we proceed. We had the current code. We created a fresh NX workspace. We then imported the code into the fresh NX workspace. And then we build and run the dev. Is it working? Nah, it broke, obviously, right? The code was not that good. But then we identify why it broke. And then we broke the current build, right? Because then we can fix the code that was not up to standard in the current build, and then we can start over again. With this, we were able to say at every single step, we stop the migration. We don't have bandwidth anymore. We still improve the code base. Because at this point, we don't know how long it can be. Maybe it's like a week, maybe it's a month, maybe it's like 3 months, right? But at every single step that we took, we improved the current code base. Then we identified some of the things that we needed to tweak in the NX migration. So, like, we're going to talk about it afterwards. And then, at one point, it works. All right. So what we needed to change to NX to be able to make like our thing work with it? We had to change some TS path aliases. We have to add like Node.js fallbacks, because even though we shouldn't use Node.js in the front end, like crypto, HTTP, and such, we all do it. So we had to support it. We had to add a small number of Webpack config. It was about 20 lines to be able to tweak a little bit of small thing, but nothing crazy. And we have to disable some ESLint rule, because ESLint from NX was very stricter than ours and didn't comply with our code. And it was too much work to migrate to that. We can do it like incrementally afterwards. Anyway, what about our code, right? We had to use CSS module properly, because we're using CSS.css for CSS modules, and turns out Webpack didn't understand that. So we had to rename stuff. That wasn't too bad. We had to use relative path instead of absolute in CSS and TS. We had to use path import that relies on the Webpack config. Like, for example, config was related to like the first like file on the source, even though it wasn't aliases for some reason. Webpack magic. And then update JS and TypeScript. Update the entry point to just export the component so that we can load it afterwards. But the biggest one, fixing circular dependencies issues. Who had the circular dependencies issues in the past? Yeah, pretty much. This was our state of circular dependencies issues. You cannot see them because there is too many of them. Basically, there was 150 loops between imports that was calling Webpack 5 to say, like, I cannot know how to start your thing because everything depends on everything, so just like, deal with it. And so it was so hard to make this, because this was like the biggest part of it. We were able to get it down to 95, which was enough for Webpack to understand how to start the application. Yay! Still pretty bad. Anyway, so this is how it looks in the end. We had our lib open source, lib pro, the console, which is the application, the console OSS, and then the end-to-end that we're running on it. All right? So now time for the biggest switch. And that was mentioning like Git history, right? So first of all, we cleaned the imported workspace. We cut a second commit, which is migrating Git MV to the new workspace. Then we had a third commit to archive a copy to the old folder for the OSS transition. And then we applied the node tweaks in a separate commit. And then we were in XLN. So hooray, right? How long did that take? 3 hours, mainly because of CI. Right, there is a CI outage in Circle CI, and so the runner didn't start and everything, but like total freeze time was about 3 hours for the whole migration. So that's cool and all, but like what about the result of it, right? What about the users? What about the developers, right? Because that's why we did this. So first of all, we got 0 bug in production. No bug in production, because in the end, given we had the incremental migration approach, then we caught them earlier and didn't cause any regression in production. Secondly, the bundle of the application went from 43 megs to 30 megs, because now that TypeScript has a broader vision of the whole workspace, then it was able to tree shake more aggressively. Right? Same for Webpack, same for TypeScript, same for everything. So this was the biggest change for our actual users. I got even salesperson, like sales engineer, calling me like, Nicolas, what did you do? This is way faster now. Like, yeah, we improved it a little bit. The dev server also went from 5 minutes to 10 seconds hot reloading. Because again, it was a single context, so no need to build every single thing in the middle. Which means that the feedback loop when you work was like way, way, way faster. And the CI got 60% faster in the worst cases. In the best cases, it was like 80% faster, because of caching and the nicety around it. All right, so is that the end, right? Like, could we stop there? Could be. You don't need to build the next big enterprise. You're not Google, right? But you could also look into architectural decoupling, right? What if you want to say, I want to limit what can import what, or like modules, right? Like, for example, I mentioned earlier, I don't want to be able to import the Pro edition into the open source one, right? And NX has lint tools for that. So you can say, yeah, we can see good, okay. So you can say, like, for example, for the scope shared, I can only import the scope shared. But like for the scope OSS console, I can import OSS console and shared. And for Pro, I can import Pro OSS and shared. What visually this looks like is a bit like this. I can enforce that we have 3 blocks within the same monorepo and same context to be able to say, you can only import what you have access to, which is great when you want to build like a multiple version of the same application, right? Then you could enforce unity of the tooling. Same config, same for VTest, Storybook, Vich, Jest, Webpack, everything. And for that, we wrote a custom plugin for it, so we can say, generate me a new library. I don't care how it's done, and it will update the thing properly, put it in the right folder. Everything will be automatic for you. And that's another thing about it, right? Because thanks to the way plugins work, you get the specificity of your tooling and your configuration out of the minds of engineers and into automation. You don't have to know about all of the needy details of like the Vite configuration or like how we configure specific things. You run NX generate library, and then you're done. That's another thing about it. Because in the end, right, coding shouldn't feel like this on a large code base, right? Trying to see, like, am I going to touch something that's going to break everything? Can I actually touch this? Will like the CI break and everything? Instead, it should be more like this, you know, like a happy dance, you know, like I'm just going to change a few things there, and then poof, it's done, right? Thank you very much.